In this video, what we're going to look at is the topic of the equation of a straight line. Now, back in National 5, we covered some of the basic skills required when we were looking at getting the equation of a straight line and working with them. What we're going to do in this video is we're going to very quickly recap those skills. We're going to expand on them a little bit, and then in the next couple of videos, we're going to look at developing and building all the skills that we require at a higher level for the equation of a straight line. Now, if we think back to National 5, the equation of a straight line took a set form. It always took the form y equals mx plus c. And within this equation, there were several key parts. So y and x represented the two variables that we were linking to one another. M and c both had a set part to do with the equation of the line itself. The c represented what was called the y-intercept. What that meant is if we were to plot the line, this is the point on the y-axis where the straight line would cut through itself. M represented another key part of the line. This was the gradient of the line itself. What that means is the slope. So this told us how the line sloped when we plotted it and when we drew it. Now, for example, line could slope in several different ways. It could slope up this way, could slope down that way, it could be a nice straight flat line. The gradient was a description of each of these. So we have to be able to calculate both parts of this when we're looking at the equation of a straight line. Now, in terms of the gradient, there's two key bits of information we need to be able to get the gradient of a straight line at this stage. What we need are 2 points. So imagine I had the 2 points x, which I'm going to say is x1, y1, and a point b, which I'm going to put at the location x2, y2. So two just generic points somewhere on our grid. We use these to calculate the gradient of a straight line using the formula y2 minus y1 over x2 minus x1. So what we do is we take the distance vertically in the y direction, we divide it by the distance horizontally, and that tells us the slope of our line. Now this, as I've said, gives us several key properties of the straight line and can come out a couple of different ways. If we end up with a positive gradient, so we end up with a positive value for m, what that tells me is that my line slopes up going from left to right. So it goes in this sort of direction. So for this one, m is greater than 0. I could also have a case where I end up with a negative gradient, and in this case my line would slope down from left to right. So that would be when m equals 0. I could also, dependent on the values I get, end up with a nice flat horizontal line there, and this would be the case when we calculate a gradient and get m equal to 0. What these tell me is the three different scenarios that I can get for my equation of my straight line. There is one scenario that we don't want to occur when we get the gradient of a straight line, and that's when we end up with something that looks like m equals some value of y over 0. We don't like dividing by 0 in maths. What this tells me is that instead of a sloped up line, sloped down line, or a flat horizontal line, what I actually end up with is a straight vertical line going up and down. So there's no change in the x direction because the x part of every single coordinate is the same. These are the four scenarios that we could end up with within our system. Now, what we're doing is when we're calculating the equation of the straight line, there's two sets of data that we're going to need. The first one is we need 1 point, so one generic point somewhere on the line, and the y-intercept itself. Okay, so if we're given that, we can calculate the equation of a straight line. Or, I can just get given two generic points somewhere on the line. If I get given either of these two sets of information, what I'm able to do is calculate the equation of a straight line. So let's imagine, I'm going to look at the first scenario first. Imagine I give you a plot of a line. It's going to be a straight line looking like that. It's going to go up here. It's going to cut the y-axis. Let's say it cuts the y-axis at 4. And I give you just a generic point along here on the line. Let's say that point's at 5, 14. And I wanted the equation of that straight line in relation to y and x. When we're doing the equation of the straight line, the first thing we have to remember is what the formula looks like. Y equals mx plus c. And what we need. So in this case, I need the gradient and I need my y-intercept. To get the gradient, we use our formula, our y2 minus y1 over x2 minus x1. Now, I said before we need 2 points. We've been given one generic point somewhere on the line of 5, 14. The only other point we've been given is the y-intercept. But that is also the coordinate of the point, because up and down here, for every point we need an x and a y, and up and down here on the y-axis, the x part of our coordinate is always 0. So we actually have a second coordinate of 0, 4, which we can plug into the gradient formula. Y2 minus y1 gives me 14 minus 4 over x2 minus x1 over 5 minus 0. 14 minus 4 is 10, 5 minus 0 is 5, so I get a gradient of 2. So my line slopes up with a gradient of 2. I also need the y-intercept, but I've been nice enough in this scenario, you can just read off that the y-intercept c is equal to 4. What I can now do is take all this information and plug it together to give me the equation of a straight line, and I can say that y equals 2x, so that mx becomes that, plus c, which we now know is 4. So the equation of that straight line in this image is given by y equals 2x plus 4. If we're given these key bits of information, great, we can use this. However, what I'm also able to do is give myself 2 generic points on a line and calculate the equation of the straight line from there. So for example, imagine I give myself 2 generic single points. So let's say I give myself negative 1, 11 and the point 2, 2. I can use these to get the equation of the straight line between these 2 points. Now, general equation still doesn't change. Y still equals mx plus c. Still want my gradient, still want my y-intercept, but I just can't read it off this time. So I'm going to have to do a little bit more to find that. But again, the first step, we still need our gradient. Label your 2 points. So let's imagine we label this one as x1, y1, and this one here is x2, y2. And substitute them into my formula. That would give me 2 take away 11 on the top, y2 minus y1, over 2 take away negative 1 on the bottom. So I'd end up with negative 9 over 3. So I'd get negative 3 as my gradient. Now, there's a couple of ways we can approach it at this point to find our c. The first is to put this back into our equation, so for our m. So we'd be able to write it as y equals negative 3x plus c. And at this point, I can substitute in either of my 2 points for my x and my y, and I should still get the same answer for c. So let's imagine we take this one here on the left. So in this I know that x is negative 1 and y is 11. So I'd get 11 equals negative 3 times my negative 1 plus c. Negative 3 times negative 1 is 3. So I've got 11. Take away 3 is equal to my c. So my c is equal to 8. If I use the other point, I should hopefully get the same answer. So y is 2 and x is 2. So I know that 2 equals negative 3 times 2 plus c. Negative 3 times 2 is negative 6. So when I shift it over, it becomes 2 plus 6. So again, c equals 8. Great, I've got the same answer for both. Doesn't matter which I use. Either way, I get the same equation. Y equals negative 3x plus my c, which is 8. And I've just shown it. So there's one way we could get it. There is actually another little formula we could use to get this. And that is the formula y minus b equals m bracket x minus a. Now in this formula, m still refers to the same thing. M still refers to a gradient. But our a and our b equal one of the generic points that we've got. So just an x and a y taken from either of these 2 points. We take the whole point with it. If we do that, regardless again of which point we choose, we should still get the same equation of the line, which will end up being, hopefully, y equals negative 3x plus 8. So imagine we choose the point 2, 2. So let's imagine my a and my b are 2, 2. I know that a is 2 from this and b is 2. So I do y take away 2 equals my gradient m, which is negative 3, bracket x minus 2. Multiply out the bracket here. Y minus 2 equals negative 3x plus 6, and then shift over the negative 2, y equals negative 3x plus 8. Look at that, same equation. And I should still get the exact same thing, even if I chose a second one of negative 1, 11. So let's just very quickly show that. Get y minus 11 equals negative 3, bracket x minus minus 1, so it becomes x plus 1. Multiply it out, you get y minus 11 equals negative 3x minus 3. add 11 to both sides. Again, lo and behold, y equals negative 3x plus 8. So look at that, I've got 4 different ways of getting my c when I don't have it, as long as I have those 2 key bits of information, so 2 generic points within my straight line. So, a couple of key things we have to remember from this equation of a straight line. 1, what it looks like. Y equals mx plus c, where m is the gradient, c is the y-intercept. Second, what it looks like depending on the gradient. So a positive slope, it slopes up from left to right. Negative, slopes down from left to right. Zero gradient, it's a flat horizontal line. And any gradient where we divide by 0, so it's technically undefined, it's just a straight up and down vertical line. We then need to know information to get it. So to get any equation of a straight line, we either need 2 generic points on the line or 1 point in the y-intercept, and we can use those to do the calculation over and over again. And again, if we don't have the c, 2 different ways of doing it. 1, using y equals mx plus c and substituting in there, or this second generic formula, y minus b equals m bracket x minus a, where m is the gradient, and the a and b come from either point in our line.